All right, today we're working with relations and functions a little bit. And again, this should be review for you, but let's kind of go through some things together. So a relation, very simply, some set of ordered pairs. Now a lot of times in math that's going to be numbers paired with numbers. It doesn't have to be, but in math normally it will be. Each ordered pair has two elements, pretty basic. The first set we call the domain. Hopefully that sounds real familiar. The second set is called the range. Now if I just kind of break this up, if we think about the way we list coordinate pairs in math, x, y, then the domain is all the x values, the range is all the y values, right? Hopefully that sounds real familiar. So if you run into something like this, what is the range of the relation? Well, you just look at all the y values. So 0, 6, 1, 11, and 3. So then we just need to find the set that's going to include those values, okay? So let's go look down here. So it looks like, of course, we've got 0, 1, 3, 6, 11. Looks like that would probably be the winner there, wouldn't it? Okay, let's keep going. Now we can also graph these, of course, plot a bunch of coordinates, and this time they ask us what's the domain. So what are we looking for? Well, domain, remember, is all the x values. So they've listed these coordinates out. So notice there's an x, x, x. Of course those x values there repeat, so not a big deal. So which set represents the domain? Well, we've got 0, 2, and 4 it looks like. So there's a winner there. Again, it's just asking for what is the domain, okay? Now let's talk and go a little more specific. Functions are simply special types of relations. So each element's paired up in a relation, but in a function, everything from the domain is paired with exactly one element in the range. So they can't repeat. Let's look at a couple visual examples. These are just called mapping diagrams. So here's our domain values. We got 1 paired up, it's an odd number, 2's an even, 3's an odd, 4's an even. Well, notice, here's the key to look for. Do any of these values in our domain point to more than one thing in the range? They don't. So this would be a yes. This is a function. How about over here? Negative points to -2, negative points to -1. 0 points to 0, positive to 1. Well, here's the key. Notice something from our domain points to two different places in our range. So that's going to be a no. That will make this one not a function, okay? Now let's talk visually. What if I'm looking at graphs and I want to decide if something's a function? And again, I hope this will be real familiar to you. You've seen this before. Vertical line test, hopefully sounds familiar. So you've got some kind of graph over here. Just imagine a vertical line. They put a pencil here to imagine you just move your pencil here vertically across the graph. Well, if it touched, or if you just imagine a vertical line, it's not very vertical, but use your imagination. If it touches the graph more than one place, any place on the graph, it's not a function. I want you to think about why that is. Well, because if you plotted these points, like right here, for example, right? This x value is 2, it's paired up with +2. And down here, +2 is paired up with -2. Same x value, right? Same domain, paired up with two different output values. That makes it not a function. That's why the vertical line test works, okay? Imagine I had a graph like that. Well, does it look like it touches more than one place? Probably not, right? Something like that. Probably not. Something like that. Definitely not. So as we get more into functions, which we're going to work with primarily, vertical line test, just a quick, easy way to decide if it's a function or not. What about something like this? Let's evaluate a function. You see this notation, f of -2. Now don't be intimidated by that. That does not mean f times -2. It means f of. Okay, and that's how we read it, f of -2. It's just function notation. When you see something like this, f of x equals, g of x equals, h of x equals, all this means it's a function. Okay, a function of x. And so f of -2 just means take that -2 and plug it in for x in the function. So 3 times negative 2 plus 4 there. So 3 times negative 2, that's negative 6 plus 4, and we get what? Negative 2. So in this case, f of negative 2 gives you negative 2. Or in other words, if you plug negative 2 in for x, the function outputs a negative 2. Alright? Now what if you saw something like this? Last little example we'll look at. They give us a table of inputs and outputs, and they want us to come up with an equation. Well, which of these equations would match this? How do you tell? Well, easiest way, just plug these x values in and see what happens. Okay, if I plug 2 in to this first one, 2 times 2 is 4 plus 1, that gives me 5. Hey, that works so far. Let's try the next one. 4. 2 times 4 is 8 plus 1. Oh, that's 9. So that one does not work, okay? How about x plus 2? 2. 2 plus 2 does not equal 5. Well, we roll that one out real quick. 2x plus 2. 2 times 4, or 2 times 2 is 4, plus 2 is 6. Hey, that one doesn't work. So we've eliminated. We could go with this one, but let's just make sure it works. Plug a 2 in. 6 minus 1 is 5. That works. Plug a 4 in. 12 minus 1, 11. 18 minus 1, 17. Hey, we've got a winner. So you just check them, okay? Plug them in, check things, see what you come up with.